Interesting. So as we move down the periodic table, you guys hopefully know we add shells, right? So in the first row, hydrogen has one shell, right? Hydrogen has one shell. But if you go to the second row, you have lithium. Lithium's in the second row, so it has two shells, right? Hopefully that's kind of familiar. Now, hydrogen being in the first row, how many elements are in the first period? That means its maximum it can have in this first shell, its maximum is 2 electrons. And I like to do dots or E's as electrons. I usually do E's, honestly. I like E's. Okay. So if I have lithium, lithium would look something like that. Now, when we're talking about valence electrons, there's a term. It's one of our definitions. Valence electron. Now, whenever I do an E, that's electron, okay? Valence electron, okay? What that means is the outermost electrons. Outermost electron. Okay. That's pretty easy, right? Huh. That's not too bad. Outermost electrons. Now, what we're talking about valence electrons. Everything in column 1 has 1 valence electron. Everything in column 2 has 2 valence electrons. That's what I'm talking about. We're going to skip the middle. We're going to go to 13. 13 is going to have 3. 14 is going to have 15. 17. 17 is going to have 7. 18. 8. There we go. What's our golden number? Do we remember? 8. 8 is the golden number. Now, what we call that is the octet rule. The octet rule. The golden number is 8. How do I want to phrase it? Elements 1/8 valence electrons. However, there's 2 elements on the periodic table that don't want 8 valence electrons. What 2 are they? There's 2 elements on the periodic table that do not want 8. They break the octet rule. What 2 elements would those be? Anybody got a guess? Hydrogen and helium. All right, I just went over hydrogen. Hydrogen can only have up to 2 valence electrons. Well, same helium. Helium's only in the same period. So hydrogen and helium only want 2. Everybody else wants the golden number 8. Does that kind of make sense? Yeah? All right. Next, what we're going to be doing is ionic bonding. All right. So I'm going to show 2 different things. One is covalent. So ionic compound, this is our first type of compound. This occurs between a metal and a non-metal. It occurs between a metal and a non-metal. Okay? Where the metal is going to lose electron and the non-metal is going to gain electron. Okay? So what happens in an ionic compound is a transfer. They transfer the electron. Okay. That's a lot of information I just threw at you. Okay? I know. Now, what I want you guys to see is, all right, where's my metals located? Left or right on the periodic table?
On the left.
That's what I'm talking about. You came ready.
I came ready.
You ready? Left. My non-metals are on my right. So if I have a metal, anybody give me a metal, maybe in the first 2 columns here.
Gold.
First 2 columns here.
Oh.
Yeah.
Lithium.
Lithium. I like lithium. lithium. All right. Now, what I'm going to show you is lithium's in period 2, right? All right. So there's 1, 2, 3. Okay. Has 3 electrons, right? This is 3. It has 3, right? That makes sense. Right. I'm going to choose fluorine. I like fluorine. Fluorine's a cool number. Right? Fluorine is in the second row as well. Okay. There's 1, 2, and then it has 7 more. So 1, 2, 3, 4, 5, 6, 7. Whew. That's cool looking. I like it. Now, what I want you guys to see is lithium is my metal. So what it's going to do is it's going to lose an electron. It's going to lose an electron. And what happens is my nonmetal gains an electron. So this lost an electron, and my nonmetal gained an electron. So what I want you to see is now I'm in the first column or first period. If I'm in the first period, how many electrons does my first period want? Be careful. How many elements are there? 2. They want 2. How many does lithium have? Boom. It's happy. It's happy, right? Everything in the first circle wants 2. Outside of that, we got to follow the octet rule. So, all right, if I look at fluorine, okay, it's the second period. So how many does it want? We got to follow the octet rule. 8, right? How many does it have in its outer shell?
No, 6.
It has 8. Outer shell. 1, 2, 3, 4, 5, 6, 7.
Oh, my bad. They had 8 on the end and
Oh, I got you. Okay. Does everybody see that? Everybody see that? Have you guys learned ionic covalent before? That's brand. Now, we're going to move on. All right, we're going to go to covalent bonds. Okay? Covalent they share electrons. They share electrons. Okay? And these occur between 2 nonmetals. Okay. 2 or more. Okay, 2 or more nonmetals. You know my favorite example? My favorite example of all time is known as water. Love H2O. H2O, right? So, if I have H, okay? Yeah. If I have an H, looks like that. And oxygen, what period is oxygen in? Period. Going left and right. 2. Okay? It's in period 2. So there's 1 period, there's 2 periods. Okay? I'm going to write my elements a different color just because my O is kind of throwing me off. So there's oxygen, there's hydrogen, there's hydrogen. All right, how many electrons does hydrogen have? Being number 1? 1. All right, it has 1 electron. This hydrogen has 1 electron. Oxygen, well, in the first circle is only going to have 2, right? Everything in the first circle is only going to have 2. In its outer shell, how many valence electrons does oxygen have in column 16? 6. Has 6 right now. Column 16 has 6. Okay. So it has 6 in my outer shell. Now, what happens now is they share. They're like, hey, you got 1, I got 1. We share, we're both happy, right? So what you're going to see is this bonds with that. Those two single electrons, single dots, they're like, all right, hey, I'm over here, my friend's way over there. We're going to hang out. Basketball, 3 o'clock. You play basketball? No? What do you like to do? Sleep. I don't feel like doing that. So we're just going to move on, you know? Then this hydrogen's like, hey, I'm going to bond with that guy. So now both elements share both of those electrons. Oh, okay. So how many electrons are by this hydrogen? 2 now, right? How many does hydrogen want? 2. Hydrogen and helium want 2. It's happy. All right. What about this hydrogen? How many does it got? That's happy. What about my oxygen? I got outer shell, only the outer shell. I got 1, 2, 3, 4, 5, 6, 7.
He's really
He got the octet. He's good. He's good to go. We're done here. That's not too bad, right?
Oh, that's
Yes, sir. Jackson? Yeah, go ahead. All right. The last thing I'm going to write down before we get to our activities, some properties. All right. So there's different properties of ionic and covalent, and we're going to determine. I'm going to give you 2 substances tomorrow. Substance A, substance B. I don't know what they are. You don't know what they are. I mean, I don't know what they are. Whoa. You got a guess? Yeah. I don't know. So you're going to get 2 substances. You're going to do a certain amount of tests to see if it's ionic or covalent. Okay. Now, if I'm going to write this. If it is ionic, ionics have high melting point. So what we're going to do, we're going to melt some of them tomorrow. All right. We've done that in the previous lab. A high melting point. Covalent is the opposite. All covalent is going to be the opposite. So instead of high, it's going to be low. Okay. Ionic is soluble in water. This is not soluble in water. Ionic conduct electricity in water. That's pretty cool. Conducts electricity. Does that mean I can make a battery using ionic compound in water?
Yes.
I know. That does not. Okay. Those are the 3 tests we're going to be going over tomorrow. Or 3 trials we're going to try out tomorrow. Let's see if there's anything else. Oh, sure. I'll write this down. These are mainly solids. These can be solid, liquid, or gas. Liquid gas. Okay. That's all we're writing down. All right. So what we're going to do is I've posted this activity to Google Classroom. All right. It will take a little bit of time. All right. So I'm allowing today to work on it and after the lab tomorrow to work on it. Okay. So I'm allowing a little bit of time to work on it, you know. All right. What you are going to do is you're going to, if you know the answers to the questions based off what I just went over, you don't have to look it up, right? However, there is, I do post, oh my word, can't find my word. I posted directions to what to Google that will guide you to the direct or right answers. Does that make sense? So in Google Classroom, what you guys are going to go to is go to Classwork Chemical Bond Web Quest. You click on that. At the very top, I say Google PBS ionic bond and click on the top link, and that'll walk you through all these answers. Does that kind of make sense?